Alright, so our next step now is to create so at this point you should have a left stepper function, a right stepper function. You should have a way of setting their speeds. You did some tests, you could delete those tests, just keep the set speeds so that we can continue to set the speeds. Alright, and this is where we control the speed. Okay, so anyway, the next step is we're going to create a function called forward, in which we can tell our robot to go forward a certain distance, and we're going to use millimeters here, so a certain distance in millimeters. Okay, and so the way that we're going to do this is we're going to build a function that takes an input of a distance and uses that to step the motors a certain amount of time. Okay, so the first thing that we're going to do is we're going to type in this right here. So it's a void function, and we're going to kind of talk about the difference here, but a void function just takes a function, and what it does is it's going to take an input and do something and then go back. So it's just going to do something and then it's going to end. And so what we're going to do is, the first thing we're going to do is we have to take this input and assign it to a variable, give that variable a name. And this name, this is kind of a local variable, or I'm not sure what the correct terminology is, but this is a variable that's kind of specific to this function. This is the only place we're going to use it. And so we'll say, okay, so int, no, float. So we want to make this a float. So what that means is that whatever this number is, it can be an integer or it can be a decimal. Since we can go really, since one full rotation is 64 times 64 steps, that's like 4,000 something steps, we can go really precise distances smaller than a millimeter. So we're going to use a float, and we're going to call this variable distance. And so what happens is when I call this function forward and I give it a value here of 100, I'm sending that 100 down to here and storing it in this word distance. Okay, and so our goal here is to figure out the number of times that we want to step our robot and cause it to step that many times. And so the last thing we're going to do is we're going to have a for statement that says for x equals 0, x is less than step count. So we're going to find out whatever our step count is, and we're going to say x, and we've got to make x to be an int, okay? X plus plus, okay? And this is where we step it forward. And so in here we're going to say left stepper dot step, and we're going to step it one time, okay? And right stepper dot step, and we'll step it one time. And let's double check that that's supposed to be capitalized in our example here. Let's see, it needs to be lowercase. So let's go back here, change this to a lowercase. Okay, and so what this is going to do, it's going to complete one step, and it's going to do as many times as we need to within step count. Also, a quick thing, as we get into longer distances, there's a maximum value for the quantity integer, and so we're actually going to make this an unsigned int, which basically means that we can put a slightly larger value in this number x. Okay, and so what's going to happen is this for loop is going to take a value of x, start at 0, we're going to go through this for, we're going to step, we're going to count x up, make it equal to 1, do this again, and we're going to keep doing this until this x value is equal to this step count, and then we're done with our forward function. So from here though, we need a way of turning distance into step count. Okay, and so this is where we're going to have to do a little bit of math here. So let's go ahead, and I'm going to do some kind of walk us through the math here. Okay, and so what has to happen is this: the we know, or we have a wheel attached to our robot, okay, and we want to have it go a certain distance, okay. Well, what we can do is, if we know the diameter of our wheel, we can say, well, whatever that distance is, if we divide it by the diameter, rather, if we divide it by the circumference, that will give us a number of rotations, or a number of times we want it to rotate. So if we say distance divided by circumference is going to be equal to number of rotations, okay. And if we have a number of rotations, we can say number of rotations times the number of steps in one rotation. And what this calculation will do here is give us the number of steps to complete all those rotations. So if we want to run one rotation, we have 4,076 steps in one rotation, then that means that we need to do 4,076 steps. If we find we need to do 2 rotations, it'll be twice that amount, okay? And so by taking this distance and dividing it by the circumference here, we can say how many times it needs to spin, all right? That gives us our number of rotations. And so then we're going to multiply that by the steps in one rotation. So distance, we'll use d, divided by circumference, giving us that number of rotation, then times the steps in rotation. Okay, so this is the calculation we need to do. Now the next thing is we also need to define this value of circumference, okay? Well, we can't measure the circumference. We'll call this distance, okay? But we can calculate the circumference. Remember that circumference is equal to pi times the diameter. Okay, so if we can replace circumference here with pi times diameter, then we should be good. And so we say, okay, distance divided by pi times the diameter times steps per rotation. This will give us the number of steps that we need to travel to go this certain distance. Okay, so let's go ahead and put this in. We're going to say, okay, we'll say unsigned int, we're creating a variable here, and we'll call it step count is equal to, and we're going to say, alright, so this is equal to distance divided by pi divided, and we can do parentheses here, so we'll say divided by pi times the diameter, and we'll call it wheel diameter. Okay, so we divide by those things, and then we're going to multiply by this variable up here we called steps per revolution. Steps per revolution. Okay, now as I was doing this, this should be good here, I put a variable here and a variable here that actually don't exist. So we need to go ahead and assign values to these variables, and we're going to be using these ones multiple times, so we're going to assign them up here. So let's do another one. We'll say const, because we don't want it to change, int pi, and we'll assign that to 3 point, this should be a float actually, I apologize, because it's a decimal. Anytime we have a decimal, it's a float. 3.14159. So value of pi. And if we want more precision later, we can add it. And then we're going to say const, we just called it wheel diameter, const, we'll call this a float too, wheel diameter, and we're going to assign this a value of 110 millimeters. Seems big. We're going to say 70 millimeters. Okay. And what I'm going to have you do is go ahead and actually measure the diameter of your wheel right now and put that value in. So put in measured value of wheel here. Okay. And you can adjust the precision here as much as you want. You can use the calipers, measure this to high precision, that wheel diameter. I think it's probably pretty close to here. So you can go ahead and change that as makes fit to your wheel. Now, when we are calibrating this, so we're telling this to go forward 100 millimeters, which is equal to 10 centimeters. If it's not going that exact distance, this is the number that has to get changed. Okay, so step count gets declared right here. We're assigning it a value. We're doing a calculation right here that's going to be used right here, okay, to step it forward. Let's go ahead and verify it. So we'll choose a board, Arduino Uno. Okay, let's verify. It looks like we're good. Okay, so you can go ahead and test this now, see how it works, see if it's working for you. And we're going to do one other thing though. This calculation right here, where we take a distance and turn it into a step count, this is something that we're going to use in other functions, okay? And so it might be helpful to take this calculation and put it somewhere else so that we can access it without having to retype it every time we want to use it. Okay, so we're going to create another function. This one we're going to call an unsigned int, okay, and the name of it will be step or distance to steps. Okay, and so what this does is it allows us to convert a certain distance to a number of steps, okay, which is basically what we did right here. And we're going to take this whole line right here, we're going to copy it, we're going to paste it here, okay, and then we're going to say return step count, okay, and so you'll notice that this is not a void function. Whenever we have a function that's not a void function, it means we're returning something, and in this case in the declaration I said unsigned int, so then what I'm returning is an unsigned integer. And so now where it says unsigned int step count equals, I'm going to replace this with distance to steps, and then in parentheses I'm going to put the distance I was given. And so what this is going to do, it's going to take this distance, it's going to send it to this function distance to steps. Okay, we're given a float distance, okay, here, and so it's going to take this variable distance, it's going to do this calculation, it's going to return the step count, so send it back to here, store it in this variable here, and then use it in our calculation there. So let's verify it again, and let's see, oh, forgot the semicolon. Now let's verify, and we should be good to go. Alright, so go ahead and test this out. When you're finished, I want you to write another function, so void backward. Okay, so you're going to do this, follow a similar process to make a backward function. Okay, you can reuse some of the work that you did, such as this distance to steps function. Your backwards function is going to be pretty similar to your forward function. Okay, and then when you're done, you'll go ahead and test it.